Today's lesson is on circles in the coordinate plane. We're going to learn how to write equations of circles if we know the coordinates of the center and perhaps the coordinates of the radius. And then we will also graph circles and do a little bit of work with tangent lines and circles. So let's start off with a theorem that says, here's the equation of a circle. If the center of the circle is here at HK, then the equation for this circle is x minus h squared plus y minus k squared equals r squared. So for instance, let's pretend like this circle over here. Let's say the center is at 3, 4, and let's say the radius is 3 units long. Okay, so for example, the equation for that circle that I've drawn over there, made up, would be h is 3, right? This would say that h is 3 and k would be 4. Okay, so I would have x minus 3 squared plus y minus 4 squared equals the radius squared, which would be 9. 3 squared is 9. Okay, so what if our center was at the origin? If the center was at the origin, then h would be 0 and k would be 0, right? And x minus 0 is just x, and y minus 0 is just y. So the standard equation for a circle whose center is at the origin would just be x squared plus y squared equals r squared. So if your center is at the origin, that's your equation. If your center is not at the origin, then you figure out where h and k are and you go from there. And as I've been saying, this is the standard form of the equation of a circle. Okay, so let's write the standard of equation of a circle whose center is at 0, 6 and also has a radius of 3 like my example. So what would I have? I'd have x minus 0 squared plus y minus 6 squared equals 3 squared. And of course I want to simplify all this. So I'm going to have x squared plus y minus 6 squared equals 9. There's my equation. All right, let's see what else we might run into here. The point -1, 1 is on a circle whose center is -3, 4. I better sketch this out. And these circles, you do not have to use your compass to draw them, but you should do a sketch just so you can see what's going on. Always do a sketch, right? So let's see, the point -1, 1. So let's say that's about right there, -1, 1. It's on a circle whose center is at -3, 4. So if that's -1, 2, 3, let's say that's our center right there. That's our center. I'll label it -3, 4. Okay, and so I know this point down here is on the circle. So clearly not a perfect circle, but it looks something like that. And I need the standard equation. Okay, well, I know that h is -3. The center is hk. Did we say that? Yes, center is hk. All right, I want to make sure that's clear. So if h is -3 and k is +4, then what I have is x minus -3. So x plus 3 squared plus y minus 4 squared equals r squared. But guess what? I don't know what r is. How can I find the length of the radius? Oh, I can draw the radius in and use the distance formula, right? So if I use the distance formula here, come down here and do it, the radius is the square root of -3 plus 1 squared plus 4 minus 1 squared. Hope you haven't forgotten the distance formula. So that is, let's see, -3 plus 1 is -2. -2 squared is 4. And 3 squared is 9. So I got the square root of 13 for my radius. But in the equation, it's x squared plus y squared equals r squared. So I'm going to square that. So what's going to go right there is just 13. So there's how I work a problem like that. I know the coordinates of the center. I know the coordinates of a point on the circle. I just find the length of the radius and substitute those values into the standard equation. Okay, pause here and you do the next one. Okay, there's what that one looks like, right? I drew my sketch over here. I didn't really even need a sketch to do this one. I wasn't paying attention, but hey, a sketch never hurts. So my center is at -5, -3, which is right there. They tell me the radius, so unlike the previous problem, I don't even have to solve for the length. I got it. So I just plug these values into my standard form of the equation, and that's what I get right there. Okay, so now let's graph a circle. The equation of a circle is x minus 3 squared plus y plus 1 squared is 16. So first thing let's realize is that the radius is going to be 4, square root of 16. Where's the center of our circle? Well, we got to figure out what h and k are. And if I have x minus 3, that means h equals 3. And if I have y plus 1 squared, that means k is -1. So there's my center right there. So I'm just going to come over here to my little coordinate plane and I'm going to go 3, -1. There's my center and my radius is 4. So I just go out 4 in all directions from the radius. So I'm going to go up 4, 1, 2, 3, 4. I'm going to go to the right 4, 1, 2, 3, 4. Left 4, 1, 2, 3, 4. And down 4, 1, 2, 3, 4. And then I'm just going to freehand this in, and you're certainly welcome to freehand it in too. It looks more like a weird looking something than a circle, but it is a circle. Okay? You graph the next circle. Okay, hope that's what you got. You know that the radius is the square root of 9, which is 3. My center is going to be at 1, -3, because h is 1 and k is -3. And so just like I did a minute ago, I plot my center, I go out 3 to the left and to the right, up 3, down 3, and then connect all those as best I can to make it look like a circle. All right, what do we got now? The point 4, -5 is on a circle whose center is -2, 3. We did this. We did one just like this a minute ago. So I'm going to let you pause here and do this one, and I'll put the solution up. So you pause and do this one and come right back. Okay, so I drew my sketch first. You see over here on the side, this is what you would call your basic egg circle. That's what a freehand circle looks like. Egg circle. I'm just kidding. It's supposed to be a circle, but it doesn't look too much like a circle. It's okay. It's okay. It serves my purposes, which is to help me figure out what I got to do. I got to find the length of the radius. So I did that right here. I draw the segment that is the radius. I use the distance formula. 4 minus -2 is +6. So 6 squared plus -5 minus 3 is -8 squared, which is the same as +8 squared. And then, of course, that's the square root of 100, so that's 10. So there's my radius. Plug the coordinates of the center into the standard form equation, and there you have it. X minus 4 squared plus y plus 5 squared is 100. Don't forget to square the radius when you find it. Okay, how about this? Write the equation of the line tangent to this circle at 2, 4. Okay, this is a good one. We haven't done one like this, so let's do this. Let's figure out what our radius is first. What is our radius? It's the square root of 17, right? I don't know why my board is writing wobbly like that, but it is nevertheless. Okay, so tangent. So let me come over here and sketch this thing. My center of this circle is at -2, 3. So let's see what this looks like. -2, 3. Let's say there's our center. -2, 3. And the radius is the square root of 17, which is about 4 point something. So I'm going to just eyeball it. About 4, 4, 4, 4. So here comes my great attempt at a circle again. Hey, that one's not too bad. Okay, but what am I looking for? I need... So let's look at this point, 2, 4, 1, 2. So let's pretend like that point right there is 2, 4. 2, 4. Okay, and the tangent line. So let's draw the tangent line that goes through that circle at that point, 2, 4. Okay, so there would be my radius. So how am I going to find the equation of this line? What do I always need when I want the equation of a line? I need the slope and I need a point on the line. Well, clearly I have a point on the line. It's the point of tangency, right? It's 2, 4. So, how could I find the slope of this tangent line? Some of you have already figured it out. I know that that tangent line is perpendicular to the radius at that point of tangency. So if I find the slope of the radius, then I know the slope of the tangent line will be the negative reciprocal. Right, you are. So let's find the slope of that radius. So on the top, I've got y sub 2 minus y sub 1. So I got 4 minus 3. On the bottom, I've got 2 minus negative 2. So that's 2 plus 2. So what have I got? I got 1/4. 1/4 for my slope of the radius. Therefore, I know my slope of the tangent line, which I'll just call little t there, is going to be negative 4. Okay, so now I got a point, I got a slope. I'm not going to use a b in my equation. I'm going to use point slope form of a line, if you remember, hopefully, that says y, hang on a second, y minus y1 equals m times x minus x sub 1. And if I plug in what I got here, then I'm going to have y, and my point, remember my point is this point of tangency right here, 2, 4. So y minus 4 equals the slope, which is negative 4, times x minus 2. All right, let's solve that for y, and I get y equals negative 4x, and then I'll have plus 8, and then I'll have to add the 4 on both sides, so plus 8 plus 4, that's going to be plus 12. So there's my equation of that line that's tangent to that circle at the point 2, 4. All right. Couple more problems here. Don't we just have 2 more? Yeah. So I'll do the first one with you, and then you can do the last one by yourself. Okay, so let's see what we got here. Find all the points of intersection of these graphs. Okay, so I got a circle. I got a circle whose center is at the origin. And the radius is the square root of 8. I know that's 2 square root of 2 simplified, but square root of 8 is between 2 and 3, closer to 3, so I'm just going to say 2 point something, and then we'll just eyeball it from there. All right, so let's come over here, do our sketch, center, 0, 0, square root of 8 for the radius. Okay, and then I want to see what the points of intersection are with the line y equals 2. Well, I know this point right here is 2 times the square root of 2, right? Because that's the radius. So I know that 2, even though I'm not using graph paper, I know that y equals 2 is going to be below that. And that's why it's really important that I do myself a decent sketch. Okay, so here's what I'm actually looking for. These 2 points right here. So how am I going to do that? I got a system of equations, right, guys? So what do? I can use substitution. Let's use substitution. And let's just plug in 2 where we have y up here. Okay? So what we're going to have is x squared plus 2 squared equals 8. So x squared equals 8 minus 4, which is 4. So x is going to be plus or minus 2. And that looks right, right? Because here's this point here. I'm going to do it really big. That point is where x equals positive 2. This point over here in quadrant 2 is where x equals negative 2. So now what do? Well, I have to plug both positive 2 and negative 2 into my circle equation. So let's use positive 2 first. Okay, and I'll plug it right into my circle equation. So 2 squared plus y squared equals 8. So y squared equals 8 minus 4, which is 4. So y equals plus or minus 2. Okay, well, let's see. When I use positive 2, I can see clearly that y can't be negative 2, right? Oh, guess what? I don't have to plug in x at all. I know y is 2. Y is 2 because it tells me that right here. So, could have saved myself a little work if I had slowed down and thought for a moment, but that's okay. So I can see that y is always 2, no matter what x is. So all the points of intersection, and I do want to write them as coordinates, so the points of intersection are 2, 2, and negative 2, 2. So there's our answer. All right, so as always, I'm going to pause and let you work this second one, and it's just a tad bit more interesting than this one, so have a good time. All righty, here's the last problem. Find my center. It's at negative 1, 1. The radius is the square root of 18, which is 4 point something. So I come over here, I sketch my circle. Now I got to sketch the line. I didn't know it was tangent till I graphed it. And so, I mean, it's possible that, you know, this line could have done something like this, but I didn't know till I graphed it. I see that y-intercept is way up here at positive 8. And it's possible they may not have intersected each other at all. I could have had that line being, you know, way up here somewhere, but that was not the case. They do have a point of intersection, so that line is tangent to the circle. And the way I found that out was to substitute x plus 8 in for y. And then when I did that, I had this lovely situation that allowed me to practice my factoring some more and, you know, using FOIL to expand those. And then when I got down to this part, after I'd combined all my like terms, before I start trying to split this up to factor, I gotta, you know, you always want to see if you can factor out a greatest common factor first. So indeed I had a 2, so I factored that out right there. That left me with x squared plus 8x plus 16, and at this point I didn't really show it here, but I could have divided both sides by 2. Right in here, divide both sides by 2, and then the 2's just gone, and 0 divided by 2 is just 0. So then when I factor x squared plus 8x plus 16, that is x plus 4 squared. And when I solve for that, I get x equals negative 4. So all I do then to find y is I plug that into the equation for my line. I certainly could have plugged x equals negative 4 into the circle equation, but why would I do that? Guys, you always want to pick the simplest equation. So that's what I did right here, and I ended up with y equals 4. So I've got one point of intersection. It is negative 4, positive 4. So write yourself a summary here, and have a nice day.